Welcome back to the Enterprise mvvm series. I'm Dave, and this is going to be session 3. We're going to start building out the ActionCommand class with unit tests. We're also going to fix a bug that was pointed out to me from session 2, and we'll show you how to do that through test-driven development practices. And then we'll kind of move forward in building out some more of our data layer and actually venture into building part of our business layer. So let's dive right in. If you haven't already, make sure to grab the latest copy of the project files. The link to the source code was in the session 2 video that I had put out there on YouTube, and that's what we'll start and pick up from. So I've got that open in Visual Studio, and the first thing we're going to do is we're going to fix a bug that, like I said, that was pointed out to me in session 2, and I actually found this later as well. And it was on our base view model class. So if we go to that guy, what was found was the way that I returned the error message for a validation error on the view model class, and again we built that using data annotations, was I was always returning the first error message regardless of the property being validated. So mistake on my part, but it's kind of cool because we're gonna actually be able to show you how to reproduce the bug through a unit test using TDD practices, and then we'll fix the bug using TDD practices. So you kind of get familiar on how you can start using these types of practices and patterns to build real software. So to reproduce the bug, we're actually gonna go to our view model tests class, and we're gonna go down here to indexer validates property name with valid value. And we're actually going to create a new test method, and we're going to call this indexer returns error message for requested invalid property. And again, we're going to build a stub view model, and we're going to explicitly just say, our required property is nothing, and we're going to create another property as well. And we'll give that guy the same attribute. Now what we're going to be expecting is that when we validate some other property on our base view model class, we're going to get a message back, and that message is returned to you using a convention by the data annotations framework. So we're actually going to come down here, set a breakpoint real quick, and show you what this actually looks like. So if I debug into this test method, we can get rid of the models window here. You can see that the data annotations framework returns back to us a validation error message based on a convention. So the convention in this case for the required field is the name of the property, and then the text the field is required. So we're going to take this guy, and that's actually, you'll notice that that's also not the property that we validated. So we're going to quit debugging, and we're going to say assert art equal, and here's the message that we're expecting, and then the actual message that was returned. And the message we're really expecting is that the some other property field is required, because that's the one we requested to be validated in our code here. So this test, in fact, is a failing test. So if we go to our test explorer and we run that, we're going to get a failing result because, of course, the messages don't match. Now to fix this, we're going to go into our base view model class where the code to do that is, and instead we're going to take this and change this to, if it's not valid, then what we want to do is get the validation result, and we'll use link methods to do this, and we're going to grab the error message for the specific member name that we were validating. Again, properties in C# are case sensitive, and then we'll say return result. If it's null, that's that's good, so we'll return that there was no error. Otherwise, we'll return the error message for that, and then down here, we'll return a null value. So now if we rerun our unit test based on those changes, now we can see that we get a passing result, because now we are returning the correct result for the specific properties being requested for validation. And then of course we'll run our unit test just to revalidate that everything still passes and we're good. So that was the bug that was present from session 2. Now moving on, we can dive into building out our ActionCommand class and the unit test for that. Now an ActionCommand is actually a relatively simple class. We're going to create that actually in our Windows library. And we're going to start off by creating a new unit test class. I'll call this ActionCommand tests. And there's a couple ways that you can actually start off building out your ActionCommand. And that actually should be test class. So we're going to have a couple test functions. So I'm going to build out the various test cases first. So we're going to have one called constructor, throws exception if action parameter is null. And we're going to go through these test cases relatively quickly. And then we're going to have another test case, and this will be called execute invokes action. And you'll understand how all this plays together, especially if you're familiar with the ICommand interface in WPF. We'll have another test case called execute overload invokes action with parameter. That'll be another test case. And we have 3 more test cases. Okay, so we've got a total of, I think, 6 test cases for the ActionCommand class, so it's really not too bad. And what we're going to start off with is actually the constructor unit test, so I'll kind of get us started. So we're going to create a new ActionCommand that we've not built out the actual class for yet, and it's going to take a null parameter by default. And we're going to go ahead and create that class ActionCommand in our Windows library. And there's a couple things that we need in here. We need to create our constructor that takes a action of object, so it can take any arbitrary object as a parameter to this action. And we're going to actually pass this down to another constructor. It takes a predicate as such. Okay, so really in this scenario, our unit test really doesn't do a whole lot. Oops, let me actually run that using the Microsoft test runner. Which was constructor throws exception if action parameter is null. Oh, and we forgot actually our expected exception attribute, which should be argument null exception. And our test should actually fail. Okay. So fairly straightforward. So since we're really passing through to this other constructor, we're just passing a null value for the predicate. So this is more of a convenience constructor when you have a command that you don't really need any conditioning to execute. It's just a command that can always be executed. But we're going to check our action object that's passed in, and if it is in fact null, then we want to throw an exception. So fairly straightforward, and that should give us the functionality we're looking for that particular test case. Now we're going to do the two execute test cases. So these ones are also fairly straightforward. So execute invokes action. Really what we're looking for is we want to make sure that when our execute call is made on the ICommand interface implementation, that it actually invokes the delegate that we've passed into it. So we're going to create a Boolean variable to store the state. We're going to create a action and basically all we're doing is we're saying when our action is executed, we're just going to set invoked to true, and then we'll create our new action command and pass that delegate in, and then we'll go ahead and execute spell execute like so, and then we'll say assert is true, and we'll pass our action in. Now you'll notice that I specified the execute method. Now by default on an ICommand implementation, you have to pass in an explicit null value for the parameter on execute. In this case, we're going to provide some convenience methods to get around that. So what we need to do now is actually implement ICommand, which is under system.windows.input. And this is actually a fairly straightforward interface to implement. So we have our can execute function, and we have an execute function that takes a parameter. Now in this case, like I said, we're going to provide just a normal execute function. So we're going to say public void execute that calls into execute, and we'll pass in a null parameter. So this is again just a convenience method more than anything else. And in execute, we're going to basically say invoke our action, and we need to store this as a class member. So we're going to say private read only like so. And actually this can be down here since we're just passing through to our other constructor. So simple enough. This should be invoked in our test case. There we go. So now if we go ahead and run that particular test, now we can see we have a passing test. So the next test we want to move on to is very, very similar. So we're going to take this code as a template, paste that in there. Now the only difference that we're going to do here is create a method body on our delegate, and we're going to do an assertion to make sure that is not null, that the parameter was passed in appropriately, and that it's not null, and then we'll set invoked to true. And when we pass in or call our execute function, now we are going to pass in an actual parameter of an object, and then we're going to validate that test case is correct. So we're going to run this test case, and of course it passes. We didn't really have to change anything about the implementation of our class for that to work, but we did want to verify the behavior of it. So I've got a couple other easy test cases to implement. So for can execute, we'll create a new action command. And this really won't do much of anything. We just want to assert that our can execute by default is true. And it's not implemented at this time, so we get an exception, which is to be expected. So down in our can execute function, we're going to do a bit of code. So we're going to basically first check our predicate if it's null. We'll return true by default. And if it's not null, then we'll actually return the result of our predicate, which would be actually some condition. And again, we need to go back up here and store that as well. So this is a predicate that takes an object. We'll do the same thing in our constructor. We'll say this predicate equals predicate. Like so. If we run this, now we get a passing test. And now we could go down to our overload test. And again, it's very similar. We're going to use this code as a template. Except in this instance, we're going to do something in our method body here. So we're going to pass in not just the action that we want to take, but we're going to define some conditions. So we're going to do int object is equal to 1, and actually int the object parameter. Like so. So basically we're going to pass in a value of 1 as a parameter, and we're going to assert that 1 equals 1 in our test. So this can be changed just to 1. And again, that test case passes because, again, we didn't really need to change much about our implementation of the code we just wrote. And then our last and final test case is going to be identical to this one. It's just we're going to pass in 0, and we want to validate that it does return false under that instance. So essentially, whoops, and we actually want to say is false. There we go. So very simple test cases for an ActionCommand class. Now there's a couple other things that we need to do. Now if you look at this code, we have the can execute change event handler on this guy. Now there was a video on channel 9. Let me see if I can find it briefly. And this is a video that was done recently on Visual Studio Toolbox. And I'm not going to play the video, but I recommend this. The guy's name is Brian. He did some mvvm best practices, and one of the things he talks about is the common approach that a lot of people take where they implement this event handler, and they will actually go through the work of subscribing to the WPF command manager. So what they'll essentially do is expand this out, and they'll say, add, and then command manager dot requery suggested plus equal value, and then they'll do the same thing for remove. I'll do remove the event. And he talks about some good points about this and how you don't want to do that, because essentially when you do this, you lose control of when your can execute function gets invoked. basically, if we were to debug through this code in a WPF application, can execute may potentially get invoked 10 times when in fact it should only be invoked once. So he advises against doing this, though the most common reason people do this is because they want that automatic control of WPF just saying enable and disable the buttons and things on my UI for me without having to necessarily invoke this event manually and having to do that yourself. So that's really the reasoning behind it. And like I said, I recommend really watching this video. I'll post the link in the description when I upload this screencast, but we'll kind of go through that. So we'll leave that in there. I usually do that as a convenience. Maybe in a future session we'll kind of dive into the details of this piece a little bit more. But at this point we're done with our ActionCommand class. We have enough functionality for it to do exactly what we want with our 6 test cases and everything. So now we can actually move forward to diving into the business layer a little bit more, and we're actually going to do some refactoring first in the business context class, and we'll show you exactly what we're going to do. So the way we're going to do this first is we're going to actually take our business context, and in the original API that I had developed here, we chose to create a add new customer method that returned a customer entity, and we took a couple parameters that were required, basically the email, the first name and last name, and that was basically our business API for adding a customer. We validated those various parameters and threw exceptions if the business rules were not met. Now I'm going to show you an easier way to declare a API surface, and this is going to set us up to be able to create update APIs as well. So we're going to do a little bit of refactoring here, and to do this we're actually going to go to our customer scenario tests, and we're going to take the first one, which was basically just add new customer is persisted, and we're going to change this unit test to reflect the new API surface that we want. And really what I want to do, instead of returning a customer entity and then passing in some parameters, I really want to be able to say add new customer, pass in a customer entity where its values, its properties and values can be modified by reference. So instead I would have our customer, and for email I would have northland.com. First name would be David, last name Anderson. So this is the API surface that I want, and we would add that, and the entity framework, once the customer is persisted, would return any defaults and things like that on the actual entity. So this is the new surface we want for our API. So then we can take this guy. So now, of course, this is not going to compile because we've just changed the test, but we've not changed the actual code. And we actually need to go and change all the other tests associated with these to reflect the new API surface as well. So we're going to do the same thing here. And I'll also show you an easier way to simplify the amount of code in your unit tests after we verify that the refactoring gives us the results that we're looking for. Oops. Customer. Okay. And we're going to do the same thing here. A lot of typing, but it's all right. All right, passing our customer. A couple more tests to refactor. So let's actually just take this template code and reuse it. So now we're going to take email, first name would be null, and then last name would be Anderson. Pass that in. Do the same thing so. And one more. For an empty string. And there we go. So we've changed all our unit tests to reflect the new API design. Now what we're going to do is actually refactor the actual API itself. So we're going to go to our business context, and we're going to change this to not return a value because we don't care at that point. And we're going to take a customer parameter. And we won't worry about code documentation for now. And we can do some things like this. So we're going to say customer.email. So we're going to do customer.firstname, customer last name, and instead we can nuke these two. We're just going to add the customer, save the changes. So that's our new API surface. So we've reduced a little bit of code. Let's build and run the unit tests. Make sure that that gives us exactly what we're looking for. So we're going to run both business context tests and customer scenario tests. And there we go. So that gives us exactly what we want. Now I'm going to show you another way to reduce some of the code, and this is just a pattern that I've come up with. So we're going to go in here, and we're going to create a class. We're going to call this check. So actually a static class, and then we're going to say public static void require. And for this, we're going to do a string value. We're going to say if value is equal to null, then throw a new argument null exception. Else if it is null, white space, and we'll just see, actually in this case, let's do this. Value dot length, actually value dot trim dot length equals 0. Then throw new argument exception. So basically what we're doing is we're checking to see if the value is null. If it is, we're going to throw the argument null exception. If it's just white space, because we're using the term function with terms leading and trailing white space characters from a string, then we throw an argument exception if the length of the string is 0, meaning it's empty. So what that does for us is that allows us to actually take these and do a check.require email, customer.email. And we could also do check.require customer.firstname, and then check.require customer last name. And we can essentially remove all of that code. We'll build, and then we'll rerun these two sets of tests. And again, everything passes. So we've essentially reduced quite a bit of code that's required, not only in our API, but we're still validating the same exact business rules that we had before. So that's kind of a pattern that you can use. And as we build out the business and data layers, we'll have additional check functions for things like, GUID values, because you could essentially require, like the primary key, the customer ID. We could do other complicated check requirements. So just a little bit of a pattern that I came up with. So now that we're done with that, we can actually move forward to utilizing this business API from our view model in our desktop client. So what we're going to do with the view is actually fairly straightforward. We're going to basically create a view that allows us to add customers to a list, and basically that's going to revolve, of course, around the email, the first name, and the last name. So we're going to go to actually our test library for the desktop client, and our customer view model specifically. And we already had unit tests from the previous sessions in relation to customer name. We were basically playing around with that concept in the first demo. So if we actually run that, just to kind of have a refresher, let's go ahead and set that guy as a startup project. There we go. We'll go ahead and run this. And I believe that the validation that we did originally was, we wanted to enter a first name and essentially last name. So we had a character and then a space, and then it would be considered valid at that point. I believe we also did a maximum number of characters. Yep, so about 32. Now we're going to remove that unit test for first and last name. We did that really just to demonstrate that you could do custom validation, I believe. So if we go back to our customer view model, I believe we had overridden the onValidate method of the base view model class to provide some custom validation. We're going to get rid of that. We don't care about a first and last name anymore. That was more just for the sake of showing what you could do with it. So I nuked the unit test, and we're also going to nuke the onValidate implementation that we overrode. And we're just going to be left essentially with customer name on our view model. And we probably won't even actually need that. So what we're going to do is our view essentially is going to be broken out into 3 text boxes. We're going to need to be able to enter a first name, a last name, and an email. And then we need a hyperlink or some sort of button to actually add the customer and persist it using the business API. And then we'll need something to display validation, and we'll need something to display a result from the business API as well. So to do all this, we're going to start actually prototyping the view just so we can visually understand what it is we're trying to do. So we're going to take this text box, and we're actually going to put this guy in a stack panel. We're going to create a couple of them, 3 total, because again, we're going to have first name, last name, and email. So we'll create some labels for each. We're going to start off with just a very basic user interface. Okay, and then we'll need a button. And we'll go ahead and put that actually in the stack panel as well at the very bottom. And we'll call this add customer. And we're going to do something else. We're actually going to, let's actually do a dock panel instead of an outer grid. And in the dock panel, there's the property for last child fill equals true. So the last child that we're going to do is actually going to be a items control, and we're going to data bind that essentially to a list of customers. But our dock will be bottom, and this dock for the stack panel will be dock panel dock equals top. So we're going to add customers to a list. So this list will be bound to a collection of customers. So fairly straightforward. And we could actually, let's change this to a list box. Okay. So a fairly straightforward form, nothing too fancy. So now what we can do that we've kind of prototyped that is we know that we're going to need a couple of things in our customer view model, but we're going to try and do this through the practice of TDD. So we know that we have a couple of things. First off, we know that when we click the button, we want it to be able to add a customer. But we also want to make sure that the specified form elements are validated, meaning the first name, last name, email, and that our button is enabled when those are only valid. So what we're going to do is go to our customer viewModel test class and create a new test method. And we're going to call this add customer command cannot execute when first name is not valid. So that's one of our test cases, essentially, to say this is one behavior that the UI should represent. So to do that, we're going to create a new instance of the viewModel. And we're going to do a couple things. First off, we're going to say the first name is null, putting it in an invalid state. We're going to say that the last name actually has value, so we'll put Anderson. And then we'll say that the email also has value, so we'll just say no reply, at northland.com, just as an example. And essentially what we're going to do is we're going to say viewModel dot add customer command can execute. And there's no parameter for it. And we want to assert that this will be a false value, meaning that because the first name is null and it's in an invalid state, that this command should not be able to execute. So this sets us up for a couple things. First off, it tells us some of the properties that we need on our viewModel and some of the implementation details. So we can go ahead and start creating these. So I'm going to cheat and use ReSharper just to automatically create some of these properties. This will be a string. We'll do the same thing for last name, same thing, it'll be a string, and same thing for email. And if you are using ReSharper, Alt-Enter to do that, Control-Tab to quickly switch between your documents, open in the document wall. We'll do the same thing for add customer command, except this is going to be a action command. So this is really the first time we're going to get to use our command instance that we created. And it can be a read-only command, doesn't need to be read-write. And what we're going to do is return new action command, where the action essentially will call into add customer, and we'll pass in some values. So we'll do first name, last name, email, and then we're going to do a predicate where it can only execute if those three values are provided. So I don't remember if we had a isValid property on our viewModel class, but we could actually create one. So we're going to do that real quick, and this is really just a side effect more than anything else, but we're going to say isValid. Actually, we'll create a property, and we'll do get, and we'll say return first name, and then again for last name, and again for email. So we're basically saying, and we'll need to create this function called add customer. So this will be a private method. And then we can actually just call into our business context, and we'll just call the context API, business context. And we'll probably need to add reference to our library from the, so from a desktop client, we'll need to add a reference to our data library, so we have access to that. So enterprise mvvm.data.businessContext. And I don't think we required any constructor parameters. So then we could just say API.addCustomer. We're going to say, let's add a new customer. I'll say the first name is equal to first name, last name is equal to last name, and the email is equal to the email. Oops. And then from there, what we can do, we know that this has the potential to throw some exceptions, But because we're validating not only on the API level, but we're validating also on the UI level, we can anticipate that we're preventing those argument null and argument exceptions from ever occurring based on an understanding of the API. So I'm not really going to wrap this in a try-catch for that, but because this actually is communicating with the entity framework and essentially a data store of Microsoft SQL Server, there still is a potential for entity framework exceptions, SQL exceptions, and other network-related exceptions. So it would be a good habit to wrap that in a try-catch block and then later do something with that exception. So we're not going to cover that in this video. We'll cover error handling and things like that probably in a future session, but we'll do a try-catch for now, and then we'll say to do in later session cover error handling, because I think that kind of warrants its own topic in enterprise MVVM applications. But essentially, if the add new customer function, and actually let's return in case a exception does occur, we don't want to execute this subsequent code, but we're going to say customers.add, and essentially we're going to add that customer object to a customers collection on the view model. So that is going to give us essentially, and again, the cool thing about test-driven development is we have this one test case that is kind of forcing us to design our view model out, because these are things that are just required for us to get the functionality we need. Now, in this case, we're really saying, add customer command cannot execute when first name is not valid, and we're really just making sure that this can't execute function returns false. So we could actually say that all of this really here, we're kind of jumping the gun. So let's comment this out, because really up to this point, and actually it's not P, it's just add customer. Up to this point, we've provided enough functionality for us to be able to validate this particular test case. So we're going to run that real quick. So first, let's make sure that everything compiles with our changes, and they do. So let's go to our test explorer. Now we should have an additional customer view model test. So add customer command cannot execute when first name is not valid. So let's run that, and it passes. So it did return false. Now we want to validate two additional test cases, and we're going to use this one as a template. So this one will be last name. So instead we'll have a first name but no last name. Okay, and again, build to get that unit test, we'll run it, and we get a passing result. And then the last unit test really would be for the email. And in this case, we could do some other things, like not just validate that the email is required, but we could use data annotation to validate whether it's a valid email address as well. So let's grab that unit test, run it, and we get a passing test. Now we could take that a step further. I think we're doing this in .NET 4.5 if I remember correct, so there should actually be a email address attribute that you could potentially add. Yep, but we're not going to cover that in this video. So we'll leave it at that. So we have our 3 test cases. So now we can go a step further, and we could say our 4th test case is that add customer command adds customer to customers collection when executed successfully. And that's a really verbose test case, but for the sake of the video, it gets my point across and what we want to accomplish. So what we're going to do is take this template, this little snippet of code here, we're going to provide a valid email address, and we're going to say add customer command, and in this case we're going to execute because we can execute it, like so. And then our assertion will be is true, and we're going to say viewModel customers count is equal to 1. So what this is going to do is force us to design what we were kind of doing before, where we're going to have a public iCollection of customers. This will be customer view model. We're going to say this dot customers equals new observable collection, because we want the change notification for our user interface. So then down here we can uncomment out this code. And again, we're just creating an instance of a customer object. We're passing that to the business API. And if all is successful, we're adding that to the customer's collection. And then in the test, we're going to validate that the count is equal to 1. So now we can run this unit test. What this has provided for us is, let's set a breakpoint here, and we'll debug this one more time just to kind of visually show you what's going on with the view model and our code that we just wrote. Again, it's not, the code isn't complicated, but sometimes it's good just to walk through it and look at the state of your object. So when we get to the point of hitting this, we can look at our view model and we can see, okay, we did provide a first name, we did provide a last name, and we did provide an email. And once that was added to the database, it was also added to our observable collection for the customer's object. So what we could do now that we verified our initial test cases have passed, we can actually go to our desktop client view. Let's go up here to the view, main window.xaml. Okay, so now let's take our text boxes, and those are already bound also to email, last name, first name, so that's good. And we need to bind our button also to the add customer command. Now in our unit test libraries, we had the functional class that built up the database. I believe with Entity Framework Code first, in version 6, maybe even 5 and later, they provided the ability for the database to be automatically created on first try, but I'm not 100% sure. So there we go. Okay, so everything worked. So we're actually going to go grab SQL Management Studio so you can actually see the data that's in the database at this point. So the Entity Framework did create the database automatically when the data context was first initialized, and it will do that with the database scheme. I couldn't remember if that was functionality that was in version Entity Framework 5 or 6. So if we look, we actually have Enterprise mvvm, and let's see, what was the name in our desktop client? So just session 2. So if we look in here under session 2, tables, there's our customer table. There's our 3 columns and our primary key. And if we actually select the data, now we can see that we have the customer object that we just created from the UI. So everything worked perfectly. So let's nuke this connection, disconnect all queries, and go back to our UI. Now I noticed the last thing is that our list box by default was displaying the type information for our customer object instead of information about the customer. Now there's 2 ways that we can remedy this. We can override the toString method on the customer to display something useful. But in terms of the UI and WPF, it's much better if you actually use a data template. So we're going to go to our list box. We're going to say list box .resources. We're going to say, and actually data template, and we'll say, I believe it's data type. And we're going to say X type is of customer, like so. And then we're going to say, let's display a text block, and we'll do run first name, oops, binding first name, and then we'll say last name, and then we'll do email. I'm just going to bunch all these together. I don't really necessarily care right now whether we do a whole lot of prettiness in the UI. We just want to display the data correctly for now. So maybe what we'll do is we'll do a run, and maybe we'll have a first name, last name, and then, well, we could do this. Let's do run, font weight, bold, first name, oops, last name, and then email. Like so. Let's run this again. And we don't have any logic to load customers into our view model right now. Everything that we're going to see in the view model will be strictly based on what we enter. So if we do, for example, Scott Guthrie, for example, and we add him to the database. Now our database was already created once. Potentially we should just be adding it. So now we have our template that was added through the UI. So we didn't have to really add any code to do that. Again, that's handled through WPF and all of its data binding functionality and templating and all that fun stuff. So essentially what we've just been able to do is through the process of test-driven development, mvvm, building a business layer with unit tests and all that good stuff, is you've basically created a very, very basic CRUD form that you could create records with. So the next, let's see, how much time have we gone so far? Probably in the next session that we'll cover, what we'll do is we'll take this and we'll turn this into, we'll grant it or provide the ability to edit the data as well as load any existing data from the database. So we'll have a true CRUD form, and it's not that much harder to do. And what that will allow us to do is actually build out a update business function. And I'll show you how to do that with very little code, and we'll share the code between add and update and all that. But essentially this at least gets you a little bit closer to where we want to be with our enterprise series. So we'll stop it there. Like I said, next session we'll start diving into the rest, and we'll see you next time.